This PowerPoint presentation is from section 14.6 of our textbook. This third video in the series for this section will cover the concepts of buffer capacity and buffer range. In a previous presentation, we talked about what a buffer does, what it's made of, and how it works. We need to add two additional ideas to our understanding of buffers, namely buffer capacity and buffer range. Buffer capacity is how much acid or base a buffer can buffer against without changing the pH too much, and is determined by the concentrations of the A- and HA components in the buffer. The larger the concentrations, the better the buffer. Large concentrations of both components give a higher buffer capacity because more buffer components are available to neutralize any added acid or base. The range of a buffer is the pH range over which the buffer is expected to be effective. Buffers are most effective at pH values close to the pKa of the acid component. Recall the Henderson-Hasselbalch equation. This equation shows us that the pH of the buffer will depend on the pKa value of the weak acid component and the ratio of the base and acid concentrations. Since we want large and comparable concentrations of both acid and base species, this means that the ratio in the Henderson-Hasselbalch equation should be close to 1. The log of 1 is 0, so when there are exactly equal concentrations of A- and HA, the pH will equal the pKa. If there is 10 times as much A- as HA, the pH will be 1 unit greater than the pKa because the log of 10 is 1, and the pH will be equal to the pKa plus 1. On the other hand, if there is 10 times as much HA as A-, then the pH will be 1 unit less than the pKa because the log of 1 over 10 is negative 1. We don't really want the concentrations of the two species to be more different than each other than a factor of 10 or so. So we say that the useful range of a buffer is plus or minus 1 pH unit. This puts some limits on what species you can use to make a buffer of a given pH. You always want to choose a conjugate acid-base pair that has a pKa value within 1 unit of the target pH of your buffer. Looking at the pairs given in the problem, if we find that the pKa of hydrogen carbonate is 10.25. So this would not be a good choice to make a buffer at pH 7. The pKa of hydrogen sulfite is 7.19. So this would be a suitable conjugate acid-base pair to make a buffer of pH 7. Similarly, the pKa of carbonic acid is 6.37. So this pair would also work. Notice that we use the pKa in each case of the acid component. So for question C, we looked for the pKa of the carbonic acid rather than the pKa of hydrogen carbonate. Finally, the pKa of phosphoric acid is 2.12, so this conjugate acid-base pair would not be a suitable pair. So out of the choices provided, only options B and C would be suitable conjugate acid-base pairs to make a buffer of pH 7. Criteria. So we're looking for the weak acid component to have a pKa between 6 and 8. Here are some guidelines for how to prepare a buffer with a specific pH value. As we've already seen, we need to start by choosing an acid-base conjugate pair that has a pKa of the acid component within 1 pH unit of the desired pH of the buffer. Next, we'll use the Henderson-Hasselbalch equation to determine the correct ratio of A- to HA concentrations to achieve the desired pH. To make our buffer, we'll use appropriate sources of the weak acid and its conjugate base in order to achieve the calculated ratio. Appropriate sources of these chemicals can include pure liquids, solutions of given concentration, soluble salts, etc. Remember also that reactions of strong acids or bases go essentially to completion and so can be used to generate the acid from the base and vice versa. In practice, other considerations like toxicity, stability, and others will influence buffer choices. Finally, you want to choose concentrations that will provide sufficient buffering capacity. Problems will sometimes state a specific concentration of either component or a total concentration of the two components together to indicate the required buffer capacity. In the next video, we'll walk through the calculations on examples of how to prepare a buffer of a specific pH value.